Okay, for this problem we are asked to change this sum of 1, 2, 3, 4, 5, 6, 7 terms in summation notation. Now there are actually many ways of doing this. I'm going to show a few ways that kind of make sense, but if you have an answer that doesn't exactly match one of the ones that I'm about to show, it's perfectly okay. The first thing that leaps to my mind would be to do this. Summation n equals 2 to 8. Now why do I start on 2? Because the numerators are perfect squares. So x to the n squared. So this would be x to the 4th, then x to the 9th when n equals 3, then x equals x to the 16 when n equals 4, and so on. Now the bottom has to be, well, the denominators are arithmetic progression. So I need to start this one off. Let's see. So the common difference is 2, so it's going to be 2n. And I need to start off on the right term here. So if n equals 2, that's 4. So let me add 1 to make sure that's equal to 5. Okay, so I'm almost home, except I have an alternating sign here. Positive, negative, positive, negative, positive, negative, positive. So I'm going to have a negative 1 in there to a power. And I want to start positive, so I'll have a negative 1 to the n there. And so that takes care of the alternating signs. Okay, so that works. Nothing wrong with that. That works. Let's talk about some other ways that this could be written. First, you could just simply change the letter. K equals 2 to 8, negative 1 to the k times x to the k squared over 2k plus 1. There's nothing particularly sacrosanct about the letter n, so that would certainly do the trick. Also notice that there's the x just is simply x here. There's not the when I plug in here, n changes values, not x. So the x just simply comes along for the ride. Okay, so change the letters, that's fine. Let's do something a little bit different. Let's now try it if I have a sum that starts on 0 this time. Then I would go from 0 to 6. So that would be my j equals 0, j equals 1, j equals 2, j equals 3, j equals 4, j equals 5, j equals 6. Then the denominator would now be 2j plus 5. So if j equals 0, I get 5. If j equals 1, I get 7. If j equals 2, I get 9. And that matches the bottoms you see down here. Okay, my alternating term will look kind of the same. If j equals 0, I get negative 1 to the 0 power, which is plus 1, so it starts positive. And then the next bit will be x to the j plus 2 squared. And so this would be, if j equals 0, I get 2 squared for 4. If j equals 1, I get 3 squared for 9. And if j equals 6, I get 8 squared for 64. So that's another completely legitimate way of writing the series, kind of shifting the index. Let me do 2 more ways of doing this. Summation I equals 1 to 7 this time. So I had 7 terms, 1, 2, 3, 4, 5, 6, 7. So I equals 1 to 7. The bottom will now be 2i plus 3. If I equals 1, I get 5. If I equals 2, I get 7, and so on. The x term will have x to the I plus 1 squared. So if I equals 1, it's 2 squared for 4. If I equals 7, I get 7 plus 1 squared, which is 64. And then I have my alternating term. Now that's incorrect now, because if I equals 1, that's negative 1 to the first, which is negative. So I can put either plus 1 or minus 1, either way, to make sure that it starts off positive. All right, one last way of doing this. Summation m equals 1 to 7. And let's see if I can do this on video live and not make a mistake. Let's do this one backwards this time. So this time, let's take this term to be the quote-unquote first term. So going backwards, this would be, let's see, so this is going to be 19 minus 2m. If m equals 1, I would have 17. If m equals 2, I'd have 19 minus 4, which makes 15. If m equals 3, I'd have 19 minus 6, which is 13, and so on. The x term will now be, let's see, what's it going to be? I want to have 9 minus m quantity squared. If m equals 1, I would have 8 squared for 64. If m equals 2, I have 7 squared for 49. And at 7, it'd be 9 minus 7 for 2 squared, which is the 4 here. And then finally, I would need negative 1 to the m, let me do minus 1 this time, so that my first term comes out positive. So all 5 of the expressions that I wrote down here look very, very different, but they all produce the exact same 7 terms being added together.